So my name is Ritu Das. I'm a new neurologist. So thank you very much for the opportunity to come and speak to you regarding preventative health. As a physician, it is typically the norm to talk to you in the clinic or hospital setting once health problems have arisen. So it's really wonderful to be able to speak with you today about prevention. So I'll start by telling you a little bit about my training and my practice. So I obtained my medical degree from the Medical College of Georgia, and then I spent 4 years in training in neurology residency at Baylor College of Medicine in Houston, and went on to practice there for approximately 7 years. So in 2017, I moved to California with my family. I spent time at Adventist Health in Paradise, California. So I joined Barton earlier this year. Thank you very much. So I joined Barton earlier this year. Thank you to Dr. Purvance and Barton Hospital for giving me the opportunity to serve Southlake and the surrounding community. Sorry, I'm getting myself situated here. So most people ask, what is neurology? What does a neurologist do? So it's the medical evaluation and treatment of problems of the nervous system. So the nervous system is the central nervous system as well as the peripheral nervous system. So neurosurgeons operate, whereas neurologists prescribe medications, prescribe therapies, and do procedures to treat neurological conditions. The central nervous system comprises the brain and the spinal cord, right? The peripheral nervous system is made up of muscles, nerves, and nerve roots. And so today we'll focus on the brain as part of the central nervous system. So what's the objective? We need to know where we're heading. So I want to tell you some basics of brain function and what brain cells need to thrive. I'd like to describe the natural process of aging and its effects on memory. We'll touch very briefly on the mechanisms in which the brain has dysregulation in memory or functioning. And finally, we'll talk about the ways that we can actually control in maintaining our brain health. So the brain's a small organ, only weighing on average about 3 pounds, but requires a substantial amount of blood supply to do its work. Without the brain functioning, many of the body's functions cease. And brain cells are particularly sensitive to decrease in blood flow and oxygen. The brain evolves over our lifespan. It does not stay the same. Alterations or early neuron death occurs in some disorders of the brain. Neuroplasticity is a concept we'll talk about, which is fundamental to brain health. So the brain organ is made up of microscopic nerves. These cells are called neurons. The neuron has a cell body, the large rounded shape, which has the cellular nucleus and other internal structures that produce energy for the nerve. The neuron has a long, thin connecting tail called the axon. Just as there are blood cells and muscle cells, heart cells, these cellular machines, the neurons, require oxygen from the blood, nutrients and energy to fuel the processes that do the job of the brain. Nerve cells or neurons communicate with each other through these processes, either chemical and electrical signals. Dendrites, or these long processes, receive these signals as well. There's a gap or a cleft in which the neurons actually receive this information and pass it on to neighboring nerve cells to transmit an electrical impulse. So over time, from birth and through adulthood, the brain grows and changes. Above, we have different brains at different time points in the lifespan. Note that normally there are changes that do occur, changes in the volume. So the younger brain is fuller in volume, and with less of the gyral normal involutions or wrinkles. There's also a change in the color of the gray matter and white matter of the brain. We see that the younger brain is not fully myelinated. Myelin is this covering, the sheath around the nerves, which helps to transmit electrical signals faster. So in science, there's always a debate, always a controversy. And for past decades, previously thought was that we are born with all the nerve cells we will ever have in life. So there is research that neurogenesis, or nerve growth, is a lifelong process, and it occurs in the adult mammal brain. And this concept is called neuroplasticity. In fact, it is the growth of neurons, particularly in the adult hippocampus, that has been clearly documented in research from scientists. The above article cites that previous processing of brain tissue actually damaged these new nerves that grew in the hippocampus, thus preventing scientists from recognizing it. So there are different names for the different parts of the brain, and brain functions lie in different parts of the brain. All the parts work together in providing different parts of our brain, our being, various inputs and outputs. Our senses, our ability to move and speak, regulate emotion and memory are in the connections between the different parts of the brain. And there are multiple complex pathways of memory. The frontal lobe works in decision-making, in planning, in language expression. And the parietal lobe helps us with spatial function, sensory perception, and calculation. The temporal lobe includes the deep centers of the memory, including the hippocampus and the amygdala, which functions in the comprehension of language, the temporal lobe. The occipital lobe works to help us process visual imagery and visual memory. And the cerebellum coordinates our planned motor action. There are different kinds of memory. Episodic memory is the kind we think of. An episode of memory. What did I have for dinner yesterday? Where are those darn keys? Semantic memory is the accumulation of facts or general knowledge. And remote memory is the long-term memory or autobiographical information. Working memory is like holding on to a bit of information, trying to memorize a telephone number for a brief duration. All these different types of memory go through different circuitry. So short-term memories then get transitioned into long-term memory. And memory is like a circuit. Encoding is creating a memory representation, and storing the memory is like stabilizing it, strengthening it. And then we try to retrieve it later on and that's the conscious recall of a memory. The question is, what is normal aging? What is normal aging memory? And is there such a thing? Though we'd like to believe that our brain in our 20s is the brain function we will have later in life, this is in actuality not true. There are subtle cognitive changes in normal aging. These changes are not pathologic. They're not a disease process. So vocabulary and general knowledge are fairly resistant and may even improve with time. Procedural memory is knowing how to do something, like ride a bike or drive a car, and this stays relatively constant over time, an implicit memory. Now, there is evidence to support that as we age, particularly as we advance into our 80s, we gain the ability to perceive things differently, gaining the ability to put together seemingly disparate concepts, being able to see forest for the trees rather than the leaves on the trees, perhaps the root of wisdom. And some things give. Visual confrontation naming is just naming an object or picture of an object as it's put in front of you. What was that tool, that thing, that person's name? Processing speed does decline over time. That's the speed with which we do things or think or plan with motor speed. Getting to the memories we hold or retrieval seems to decrease in performance as well. And there are gender differences in the brain volumes of the subcortex, the subcortical portion of the brain. That decreases in volume at a faster rate in men greater than women in healthy subjects age 18 to 86. So this brings us to disorders of memory, or dementia. So the word dementia has become synonymous with memory loss, but in actuality, dementia is a term of loss of higher order brain function. This could be language, visual functioning, procedural memory, or what's called apraxia. There are dementias that even affect the personality. Dementias or neurodegenerative disorders occur slowly. Most occur without a family history. So, dementia is a very general term for progressive loss of cognition or thinking that impairs one's function in daily living. This could be complex tasks or even basic tasks. And this varies for different individuals and can range from an inability to write a dense manuscript, getting lost driving in a familiar place, or like tasks of forgetting how to dress. There are varying degrees of dementia, mild, moderate, and severe. Worldwide, dementia affects approximately 50 million people, with the possibility of tripling in number by 2050. And these statistics are from the Alzheimer's Research Group in the UK. Dementia is not an inevitable part of aging. More women than men acquire dementia. And with age over 85, there is an increasing risk of acquiring dementia. So from the New England Journal of Medicine from 2013, the total annual societal cost per case of dementia is $41,000 to $56,000 per person annually. And this is data from 10 years ago, as I mentioned. And with the escalation of aging population, this will likely increase over time. The main source is institutional and home-based long-term care, rather than the cost of medical services. But as anyone with a loved one, family, or friend with dementia, we know that living with dementia, there are other challenges than just financial. Dementia can come from many sources. Physical damage to the brain, such as a blood clot or bleeding in the brain, kills or scars nerve cells or disrupts the communication between them. A blood clot stops blood flow to parts of the brain, depriving the nerves of oxygen and nutrients. So here is an image of a cerebral angiogram. This tree-like structure is the blood vessel branching of large and small blood vessels to one hemisphere of the brain. Blockage or rupture of these blood vessels causes stroke. Vascular dementia is the name of a type of dementia from recurrent or large strokes. It is the second leading cause of dementia after Alzheimer's dementia. Now, trauma can similarly damage nerve cells as well, even without apparent visible structural damage. The nerve axon, that long structure that we talked about previously, can have damage and impair communication with other nerves, and this can be at a microscopic level. Toxins, such as tobacco, increase oxidative stress and increase stroke risk. Heavy alcohol use is well established to cause a type of dementia. Illicit substances, such as cocaine and methamphetamine, cause strokes, both ischemic as well as hemorrhagic. Heroin can cause oxygen deprivation to the brain. And there is increasing controversy regarding cannabis, and particularly heavy use of cannabis and frequent use, which has demonstrated adverse cognitive effects in short-term studies. So here is an MRI, a magnetic resonance image of the brain in a person who's had strokes. So what we see here are these small, circular, dark regions, scarring from small strokes, and this dark and white region in the far corner, which is suggestive of a larger stroke in the past. These disrupt the connections between the nerves and can cause memory and thinking problems. Less known is that metabolic deficiencies, such as that of vitamin B12, being left untreated, can actually lead to a dementia. Thyroid problems as well, untreated, can lead to long-term memory problems. And severe kidney and liver disease can predispose to dementia. There are infections as well that can cause long-term memory loss. These include AIDS as well as syphilis. And there are other primary central nervous system disorders which can cause dementia long-term, including multiple sclerosis and even intractable epilepsy or uncontrolled seizures. There are distinct forms of dementia which are caused by different accumulations of abnormal substances or proteins within nerve cells. This can disrupt the function of the neuron or nerve cell and accelerate neuronal cell death. Some of you may recognize the names Alzheimer's dementia and Parkinson's dementia, and these are caused by different pathologies or different causes. Some conditions are common, and the others on the lower part of the table are much rarer. Alzheimer's disease is the most common type of dementia, and scientists have been studying these various brain cell accumulations of abnormal proteins to study which potential therapeutic target might work to fight these diseases. This is the reason why drugs for one condition don't always work for a different condition. So here are some schematics and real-time imaging to show the difference in the brain volume of a normal brain versus the person with dementia. Now, atrophy is a term used to describe a decrease in the volume of the brain. Atrophy is not specific to Alzheimer's disease, but can occur in any type of dementia. brain atrophy typically begins years before the physical signs of dementia develop. And to be fair, in the normal aging process, there is some degree of atrophy that occurs, but in processes like a dementia, the atrophy is out of proportion to what is expected for that person's age. Neuron loss and atrophy in Alzheimer's disease occurs based on numerous theories. So there are abnormal signaling alterations and abnormal proteins that cause neuron loss. Toxic substances accumulate within the nerve cell that shouldn't be there. Neurofibrillary tangles are these paired helical filaments that have tau protein. Neurofibrillary tangles are these clumps or aggregates of tau protein inside the cells. Extracellularly, outside of the cell, amyloid beta protein accumulates in the gray matter superficial surface of the brain in collections that are called senile plaques. It is the amyloid beta protein which has become of interest to scientists in the development of drug trials to stop or prevent this protein from accumulating in the brain in the hopes of treating or preventing Alzheimer's disease. So neuron death and destruction of the synapses are also involved in the Alzheimer's disease pathology. Brain-derived neurotrophic factor is a chemical growth factor that actually increases neuron growth, and this is felt to be deficient in Alzheimer's disease. Acetylcholine is a chemical that is decreased in the frontal lobe in the pathology of Alzheimer's disease. And glutamate is an excitatory chemical in the brain that has reduced action in Alzheimer's disease. It's based on all of these suspected processes that are felt to be causative for Alzheimer's disease. So here's a picture of a normal neuron. Neurofibrillary tangles are those blue clumps you see, aggregates of tau protein. Tau comes off of this microtubule and becomes this thread-like structure, neurofibrillary tangle. Tau protein is released with destruction of the microtubule within the structural framework of the neuronal axon. Here is a microscopic slide of brain tissue where we see the neurofibrillary tangle of tau. And here you can imagine a senile plaque on the superficial surface of the brain, made also of disintegrated supporting cells. And these cells are called microglia or astrocytes. So there are typical patterns actually that we see specifically in Alzheimer's. And this relates to the progression of beta amyloid and tau deposition and where they occur in the brain in the stages of Alzheimer's disease. So dysfunction begins in the deep temporal or hippocampus region. If you recall, the temporal lobes are involved in memory, naming, language. Then over time, the deposition of protein spreads to the parietal lobes. Again, if you remember, the parietal lobe functions in visuospatial function, calculations, orientation in space. And later in the disease, the abnormal proteins of Alzheimer's develop into the frontal lobes, where we have our executive function and planning. So some risk factors for Alzheimer's dementia cannot be changed. And there are some genetic factors as well. Apolipoprotein E, a specific subtype, if a person has 2 copies of this gene, that person has a 50% risk of developing Alzheimer's at early onset, at less than 65 years of age. Now, if a person has 1 copy of the apolipoprotein E gene, then that person has a 50% chance of developing Alzheimer's in their 70s. Other genes as well, APP, presenilin 1, presenilin 2, are also implicated in early onset Alzheimer's dementia. We typically don't test for this unless a person is very young and has a very strong family history of dementia. Years of education has also been implicated as a risk factor for Alzheimer's. If years of education is lower, this can be a risk, and if years of education is higher, it can be protective. As we mentioned earlier, gender, being a woman, is a risk factor as well. Now, head trauma has come into the limelight as CTE has gained attention. Chronic traumatic encephalopathy is a condition of young onset dementia in the setting of recurrent head trauma, particularly seen in NFL athletes. And it has a striking similarity to Alzheimer's, but is still considered a distinct clinical entity and does not yet have a clinical diagnostic algorithm. Nonetheless, head trauma is a risk factor for developing dementia. Modifiable risk factors. There is a significant overlap in the risk for developing strokes, the risk for heart attacks, as they are many of the same risks as developing Alzheimer's dementia. Thus, control of high blood pressure, excess weight, high blood sugar, high cholesterol, and avoiding smoking can modify or reduce your risk for Alzheimer's dementia. Blood sugar and dementia. So this is a New England Journal of Medicine article from 2013. It followed 2,000 individuals over 7 years. On average, they were age 76. 500 of them developed dementia. The study included persons with diabetes and those without diabetes. Now, there were significant findings in the higher risk of developing dementia. The non-diabetic persons with a higher average blood sugar, on average 115, in the preceding 5 years, had a higher risk of developing dementia than the non-diabetic persons with average blood sugar 110. In diabetic persons, the higher the average blood sugar, greater than 190, had a greater risk of developing dementia than diabetic patients with a blood sugar of 160. So the conclusion that was made was that higher glucose levels were associated with an increased risk of dementia in populations with and without diabetes. High blood pressure and dementia. In this clinical trial, Systolic Hypertension in Europe trial, patients with hypertension had aggressive blood pressure lowering, and this reduced their risk of developing dementia. In the Progress study, cognitive decline was only 9% with people who were treated with blood pressure medicines, and it was higher. Cognitive decline was 11% by lowering blood pressure with medicine. The Finger study in Finland demonstrated a decrease in cognitive decline over 2 years with diet as well as blood pressure lowering. So the good news. We know that there are things we can do to prevent and possibly slow the progression of dementia, and in particular, Alzheimer's disease. There is substantial variability in how individuals with dementia progress. Why? The brain can change. There is a reserve we can build to protect our brains from degenerative processes. There is data that persons with rigorous and challenging occupations or hobbies and those that remain intellectually engaged do better. There's a delay to cognitive disorder symptom expression, and a rate of progression of dementia is slowed. Cognitive reserve has been linked to education, literacy, occupation, socioeconomic status, and leisure activity. So I'd like to provide you a guide with elements of a path to optimum brain health. There's substantial ongoing research into this field, and that translates into meaningful life changes that are accessible to anyone and everyone. What are the fundamentals of improving your brain health? I encourage you to change the perspective from transient or temporary diets to life-lasting eating habits and plant-based source of energy for your brain. Improve oxygen and blood flow to the brain and feel the cognitive benefits of improved focus and retention. Rest and restore the brain and reap the benefits of improved cognition. Improve the ability to regulate emotions with stress management, and engage in social interaction that enriches our human experience. Continue to learn no matter what stage in life you're at. So the goal of food intake is to nourish our brains and our bodies. Small changes can have big impacts. To change to whole grains if possible. Fill half of your plate with vegetables or fruit. Reduce red meat or replace it with fish. Adding nuts to enhance protein consumption. It is the inflammatory reaction and oxidative stress, the chemical process that damages the neurons. Highly inflammatory foods, we all know, include high sugar foods, refined carbohydrates, and unhealthy fats. To make our neurons fire and function better, part of the process is to reduce the consumption of damaging foods to our brain. We often indulge in comfort foods to alleviate stress or reward our brains dependent on the high these foods provide. Through mindful practice, we can learn to listen to our hunger signals and respond to our health benefit. So I give you some examples of different styles of eating. Mine is a combination of the Mediterranean and DASH style of eating with the specific goal to reduce dementia. Whole grains, berries, green leafy vegetables, olive oil, poultry, and fish. The Mediterranean eating practice is associated with reduced risk factor for developing cardiovascular disease. It's a sustainable diet recognized by the World Health Organization. It's cuisine in countries by the Mediterranean Sea, and these countries have the longest longevity in the world. In the Mediterranean diet, there is an increased daily consumption of vegetables, fruits, whole grains, and weekly intake of fish and poultry, beans and eggs. There's moderate dairy and limited intake of red meat, and moderate consumption of red wine. It's a plant-based way of eating. DASH stands for Dietary Approaches to Stop Hypertension. It truly focuses on salt or sodium intake reduction. It was developed to lower blood pressure without medication. Now, talk to your doctor, don't stop your blood pressure medications, and consider this a way to reduce blood pressure in conjunction with medications, the goal being 1.5 to 2 grams of salt intake daily. Physical exercise enhances neuroplasticity. The human brain adapts to changing demands by changing its function and structure, enabling learning and acquiring new skills. How? Neurogenesis, or neuron growth. Synaptogenesis, connections between neurons are developed with physical exercise. And angiogenesis, growth of blood vessels in the brain, as well as increased release of neurotropins like brain-derived neurotrophic factor, that which increases nerve growth. There is a wealth of evidence for the positive effect of physical exercise on the brain and the brain volume. In a simple search online of cardiovascular exercise and cognitive health, there are over 1 million results, 15,000 since 2018. The titles include Effects of Aerobic Exercise on Hippocampal Volume in Humans, a Systemic Review. Aerobic Exercise Training Increases Brain Volume in Aging Humans, 2006. Aerobic Exercise Effects on Cognitive and Neuroplasticity in Older Adults, 2009. This is not new information. And Physical Activity Predicts Gray Matter Volume in Late Adulthood, the Cardiovascular Health Study, 2010. There are so many health benefits to exercise, about elevating mood, improving sleep, reducing the risk of stroke and heart attack, and in the reduction of risk to Alzheimer's dementia. There are several clinical studies demonstrating that exercise can actually slow or prevent hippocampal decreased volume. What kind? Cardiovascular or aerobic exercise 150 minutes per week is recommended by the American Heart Association. The more rigorous, the better, to drive and pump the heart to increase blood and oxygen to the brain. However, even a little, even a modest amount, is beneficial to the brain. 8 to 10,000 steps a day. Stationary bike, walking in a heated pool, running, swimming, hiking. An activity that you can enjoy, an activity you can sustain. Exercise to your fitness level. Ask your physician if you have a medical condition or injuries that limit your mobility or your endurance. Strength training, stretching, balance are cores to add to cardiovascular exercise to provide strength to muscles and bones and prevent falls. Many studies look back at the past and investigate the risk of dementia. I like this one because it's compelling in that they look forward. This was a longitudinal study completed in women following people in midlife. They were studied for over 40 years. They looked at who developed dementia and what their distinguishing differences were. Midlife cognitive and physical activities are independently associated with the reduced risk of dementia and dementia subtypes. Improving depth and quality of sleep helps to consolidate learning and memory. Sleep deprivation affects attention, working memory, and hippocampal learning. The greater the amount and the longer the duration of sleep deprivation, the worse the accumulating attention deficit. All of you yawning know exactly what I mean. A special type of brain scan called the functional MRI showed changes in sleep-deprived people. The prefrontal lobe, parietal lobe, and its connection with the visual processing centers are affected. Sleep is a complex interplay of hormones and chemicals, connections in the deep parts of the brain, brainstem, and hypothalamus. From the National Sleep Foundation, there are ways that we can improve our sleep hygiene. We need to go to sleep at the same time and awaken at the same time every day. Avoiding caffeine after 2 p.m., avoiding excess alcohol, and late, heavy meals. Talk to your physician if you think you have symptoms of a sleep disorder or chronic sleep deprivation, as this can certainly contribute. Avoiding daytime naps, turning off all electronic blue light emitting devices, setting bedtime routines, and trying a relaxing activity. Talk to your physician also if you're taking prescription medications or over-the-counter supplements to aid your sleep, as many of them can have long-term negative impact on cognition. Stress can provide a beneficial function in our lives. It's meant to perform an adaptive function, to keep us alive in a dangerous situation. Chronic stress, however, keeps the body in a hypervigilant state, fight or flight, with elevated cortisol levels, a hormone that raises blood pressure and blood sugar. So chronic stress can cause harm to our brains. It can cause cognitive impairment, reduce prefrontal lobe function, and change chemical transmission in the brain through decreased expression of activating glutamate receptors. Chronic stress can actually promote senile plaque deposition and neuronal injury in animal models of Alzheimer's dementia. Meditation as a practice is one of focused attention. It's often perceived that the goal of meditation is radio silence of our minds, but rather the objective is a way to regulate and not react to thoughts or emotions. There are numerous studies on the health benefits of regular meditation practice on cognition. Studies that with functional MRI show blood flow changes that are increased connectivity of the frontal lobe, the prefrontal lobe particularly, our most evolutionarily developed part of our brain, and even increased gray matter cortical thickness in deep parts of the insula, part of the frontal lobe. There's also decreased connectivity with the fear centers, like the amygdala. Meditation additionally has been helpful in anxiety and depression management. Meditation can be as simple as walking, mindful breathing. And there are a number of online free tools or phone apps available to guide you through meditation if it seems too hard to do on your own. A rich social network can be protective in preventing dementia. Preventing isolation and loneliness are key factors. Cross-culturally, studies have reproduced this finding. Trials in China and in Sweden each have shown that social engagement decreases the risk of dementia. With today's access to technology, social media, and the internet, this can be a way to stay connected when distance or mobility limits our interaction with others. But it can't replace the in-person interaction with friends or family and those cognitive benefits. It's never too late to learn. Keep your brain active and mentally engaged. The beneficial effect of cognitive stimulation appears related to the duration and number of activities engaged. Ongoing experiences in late life have a great deal to do with cognitive reserve. Increased involvement in late life cognitive activity has been associated with slower cognitive decline. Reading books, traveling, learning a new skill or hobby, volunteering are all ways to keep cognitively active. So as we end this evening, I hope you'll take away with you that there are ways to improve your brain health, your overall health, not just for the promise of a better tomorrow, but to enjoy the benefits of cognitive health today. Thank you very much for your time and attention. And now if anybody has any questions. Yes, would you stand, sir?
You were talking about education. I didn't quite hear how that works.
So there have been a number of studies to try to understand why some people with dementia seem to fare a bit better, seem to be doing a bit better. And so level of education has been implicated as possibly one of the reasons why. As in, if a person has, let's say, college or graduate education studies, have been involved in professional life for decades, this person seems to have a bit of a protective effect. So they seem to do better or seem to get diagnosed later in life with dementia. And so that's the risk that's being detailed. Yes, in the back.
You talked briefly about genetic markers that could indicate dementia. We don't usually test for that. What do people have to
Very
start,
good question.
start thinking about that?
I think, as you can see, there's a lot of acquired risk factors in dementia, the regular stuff, right? So I think of if a person is starting to develop dementia, true dementia, before the age of 65, in their late 50s, in their early 60s, and if they have a family history that involves direct family members, more than 2 direct family members, that appears suspicious. And often, as a general neurologist, I refer them to a specialized memory center where they might do further genetic studies on that person. In routine practice, that's typically not done. Yes? I'm not aware of any particular differentiation. All right, that's it. Have a good evening.
Hi, I'm Michael Smith for Nevada Trails. Tonight, a very special show. I give you Lacey J. Dalton. Enjoy.
Come from California, come from Kansas too. Some come down from Canada, maybe Timbuktu. Well, some of you have money, more of you have none. You're all looking for something. Every mother's son. And you say you're feeling burned out, you could use a little space. Come on in, you restless heart. Last wild place. Well, some of us are scared to live, some are scared to die. Some of us will tell the truth, but more of us will lie. Though some were born fools, some love only one. Some hearts have been broke so bad they cannot trust no one. And you say you're feeling burned out, you can use a little space. Welcome home, you restless heart. Last wild place. Feel that wind softly blowing, the sun that's smiling on your face. That honey wine is always flowing here in the last wild place. Hey! Every day. We're so glad to see you, cousin. Come on disgrace. Don't look back, it don't mean nothing. You're in the last wild play. Well, those who live for power, those who live for fame, those who love the gold too much to do anything to gain. Well, the brave among us fight the fight, the coward always run. Every soul has secrets, boys. 1, 2, 3, every single one. And you say you're feeling burned out, you could use a little space. It's right there in your restless heart. Last wild breath. We're so glad to see you, cousin. Come on, laugh, it's no disgrace. Don't look back, it don't mean nothing. You're in the last wild play. We're so glad to see you dancing. Let your hair dance, it's no disgrace. Don't look back, it don't mean nothing. You're in the last one. We're in the last one. We're in the last wild play. Okay. Boys who robbed the train down in California pouring rain. One got hit in his horse wagon. We got no place to go home. Go home. Hey, mama always said I'd turn out bad. If you're no damn good luck, you're no good luck. Chip on my shoulder that I've always had. 'Cause I got no place to call home. Call home. Hey, Billy got shot up in the war. He swore he'd never ride no more. That's what the devil whiskey's for. Course I have been told. Got no place to go home. Go home. Hey now. Boys looked around, Donnie and his poor horse was down. Last week he said, made a chill run down. Says I got no place to call home. Call home. Hey, lady said, better get on back. That sky is looking mean and black. Bury that gold in an old wine shack. We got no place to call home. Call home. Hey, nothing was ever like before. We swore we'd never ride no more. That's what the devil whiskey's for. Or so I have been told. We got no place to go home. got no place to go. Go, go, go. Up in the Story County, where the wild ponies run, gold was mine that fueled the Civil War. There's a fierce but friendly people, and if you ask them to a war, they'll tell you there's still a lot of things worth fighting for. Up in the Story County, Mustang still runs free. Eagle soars above the pinyon pines. You know these horses stand for something that is precious and more rare, more silver and the gold from that old mine. So let them run, let them wild ponies run. Don't you brand them, don't you break them. Don't you let the killers take the single one. Let them run. World where fences scar the earth from sun to rising sun, there's still a few proud places left where we let the wild things run. Let them run. Up in Story County, in the high Nevada hills, freedom rides the wayward western wind. The Mustang is a sim with its wild and fiery will of the way the West will never be. So let them run, let them wild bodies run. Don't you brand them, don't you break them. Don't you let the killers take the single one. Let them run, let them wild ponies run. Don't you brand them, don't you break them. Don't you let the killers take the single one. Let them run. Oh,